We all know that clouds come in many shapes and sizes, but did you know that though their shapes may seem random, they are actually an important clue to the type of weather that may follow?
A cloud is a condensed mass of water vapor above the ground made of ice crystals, water droplets, or a combination of both. Clouds are classified by their appearance. Here are a few. Mammatus clouds are shaped like a pouch. They are an indication of extreme turbulence in the upper levels of the atmosphere. Mammatus are a strong sign of approaching severe weather. A cirrocumulus pattern is rare. It's also called a mackerel sky. The clouds are thin, usually forming between 20 and 25,000 feet in the atmosphere. Cumulus are puffy and often resemble cotton balls. They mean fair weather. These clouds are made almost entirely of water. Cumulonimbus clouds are thunderstorms in the making. They are large with boiling tops. The sky behind a cumulonimbus may be blue, but don't be fooled. Violent weather, even tornadoes, may be on the way.
Autumn storm to hit the west coast in 50 years rips a path 1,000 miles long and 125 miles wide, extending from California to British Columbia. In the Oakland-San Francisco area, a 3-day deluge dumped 6 inches of rain, a record downpour. Sewers couldn't handle the water, and the rising waters flooded streets and highways. The city of Oakland was isolated for more than a day, and California alone counted 16 deaths. As the fury of the storm mounted, so did the casualties and damage. At least 46 persons died, and damage is estimated at many millions. In Oregon alone, the storm loss is $150 million, and federal aid is being rushed to the hardest hit areas where many hundreds are homeless.
And we're going to take a look at the answer, and after that we're going to talk about the 3 and 4 types of clouds that we can find and how they are formed. And we always talk about clouds. We can see them on our satellite pictures when we show you satellite pictures here at the Weather Channel, and it shows you where our storms are moving. Well, let's talk about how those clouds are formed. They're actually formed in about 3 different kinds of ways. They can form on basically a very sunny day when we have a lot of sunshine in the air and the air starts to warm. Like on normally a day when you leave for school, you've got a lot of sunshine to start out the day, and then pretty soon by the afternoon when you come home you have some clouds in the air. Well, the reason for that is we have a little particle of air, let's say, and as it starts to warm up, that sunshine starts to do its work and it warms it up and it starts to rise. And as it starts to rise, it cools, and cool air can't hold as much moisture as the warm air can, so it starts to condense out, and that's what we see with our cloud. Now, the second way we can see clouds, frontal systems. We talk about frontal systems a lot here on the Weather Channel. Anytime you see low pressure approaching, we always talk about thunderstorms and rain and clouds. So that's the second way we can get some thunderstorms. The third way is around mountains. A lot of times when we have wind and it's coming up and over the mountains, it can't go through the mountains, it's got to go up and over it. It's forced up and over the mountain, and as it's forced up, it cools. The same as our little particle when we were talking about the sun. Well, that particle is cooling too as it goes up the mountainside, and it cools, and it condenses out, and we form a cloud. Now, let's talk about the different kinds of clouds that we have. First off, here's a graphic of what we just talked about. Our moist air rises, it reaches a certain level in the atmosphere. At that level, we call condensation, or it condenses out, and that's when our cloud forms. We get the water droplets and the cloud. First off, we have cirrus clouds, and those are the wispy kind of clouds. It kind of looks like cotton candy up there, and that's where they're way up in the atmosphere. Normally they're about 20,000 to 30,000 feet above the atmosphere. They're really wispy, and a lot of times you can see, maybe at night when you're looking at the moon, you can see a halo around the moon. Well, those are cirrus clouds, and they're basically made out of just ice crystals. Stratus clouds, well, those are the clouds that give us a real cloudy day, real ugly kind of day when we have clouds all across the atmosphere. It's just a gray day. Well, those are called layered clouds, stratus clouds, and they're generally below 5,000 feet. And a lot of times if they're real close to the ground, there actually can be fog. Fog actually is a form of a stratus cloud. Now, the third kind of cloud, the cumulus cloud, those are the big puffy clouds that you see when you come home from school, those little puffy clouds in the sky. Those are cumulus clouds, and they can be anywhere from 4,000 feet off the ground up to 60,000 feet, and when they grow real big, they grow into thunder clouds or cumulonimbus clouds, and those are the clouds where we see our severe weather.
Several elements are necessary in order to encourage development of thunderstorms, and among those elements are moisture and strong upper-level winds. Dave Schwartz explains.
Did you know an average of 45,000 thunderstorms occur each day? They can happen anywhere at any time. When air at the surface of the earth rises, it cools, so moisture condenses to form clouds. This is the cumulus stage. At this point, the storm consists entirely of updrafts. If there is a strong wind aloft, like a jet stream above the cloud, air is pushed off the top, allowing warm, moist air to be drawn in at the lower levels. This adds energy to the storm. Next, the water droplets and ice crystals that make up the cloud become too heavy for the updraft to support, so they fall. As they drop, they pull air downward, creating downdrafts. The final result, a mature thunderstorm, one that produces thunder, lightning, and in extreme cases, tornadoes. Dave Schwartz, the Weather Channel.
All right, well, we were talking about the different ways that clouds form, and remember now, you have to remember this, 3 ways. 1, the heating of the day, 2, a front, or 3, up a mountain. We're going to show you all 3 of these if we have enough time here. But first, remember Jody was telling you about the stratus clouds, the layered clouds that are generally below 5,000 feet. Do you know a very common form of stratus clouds? Fog. Now this is our foggy travel frame, and I'm just showing you where we're going to see some fog, but fog is a form of a stratus cloud. It's just a cloud sitting on the ground, and it's a layer, all right. What other type of cloud? Well, we were talking about the cumulus clouds, and actually this looks more like a cumulonimbus cloud here. You know, cumulonimbus clouds are those clouds that you frequently see during the summertime. When you get the sunshine, it starts off clear in the morning, and the sun heats up the atmosphere so that the moisture condenses, just like Jody was telling you. And then in the afternoon you get thunderstorms. Well, we also find cumulus clouds producing thunderstorms along frontal systems, and boy have we had some active weather along this particular front. And then here's another front that worked its way through the Rockies, and the front and the mountains both combined to help produce some clouds in areas of Montana today. But look at all the clouds along this particular front. Notice how a lot of bright white tops here. When we're looking at a satellite picture and we see a lot of bright white tops on this type of satellite picture, which is called an infrared satellite picture, the bright white tops indicate the cold tops in the clouds, and they're very high up. So we've got a lot of pretty tall thunderstorm clouds in here. Some milkier clouds where we're not as dense with the clouds on the satellite picture. Look at the northwest here, new storm system. Satellites are very important to us in indicating where storm systems are. And there's a lot of clouds with this, and we're going to see quite a bit in the way of rain and also some snow. In fact, let's put this into motion and show you. Here's our front. Remember our satellite picture? The fronts are fairly key ingredients in getting the lift that is necessary to produce clouds. We also need moisture in order to produce clouds, and the Gulf of Mexico is a wonderful source of moisture, and that's why we're seeing the moisture being drawn in from the Gulf of Mexico. You can see it with the direction that the clouds are taking. All right, well, we had some active thunderstorms with these clouds, and that happens sometimes too, and we'll continue to see that probably through the night tonight as well, those big old cumulus clouds. Well, you can find out more about clouds in your weather classroom book. You can also